Hi, so this is the video lecture on graphical methods for two variables, in other words, bivariate data. So when we look at two variables, what we're really interested in is the relationship between them. And there's three kinds of relationships we're going to look at based on whether we're looking at quantitative variables, qualitative variables, or one of each. So let's start with quantitative variables. So in this example, which I made up based on a premise from an old episode of WKRP in Cincinnati, we've got two people on the show. It was two TJs drinking increasing amounts of alcohol and taking a reaction time test. And so we've got, for the first person sober, the reaction time was 9/10 of a second. The second person sober was 0.95 of a second, etc. All right, so we're going to look at a scatter plot. Let's go over to SPSS, and here's the data. To do that, we're going to go to Graphs, Legacy Dialogues, Scatter Dot. All right, so Graphs, Legacy Dialogues, Scatter Dot. We're going to pick the simple scatter, click Define. Now, one thing I should tell you is that when you're doing a scatter plot, you usually have, or not usually, but sometimes you'll have one variable that's really the predictor and the other one's the predicted. If you have that, and in this case we do, the one that's the predictor is going to go on the x-axis. So we really want to think of beers predicting reaction time. So let's put beers on our x-axis and the reaction time on our y-axis. We'll click OK, and it should give us a scatter plot. Okay, so it shows us what that relationship looks like. So what does that tell us here? It tells us that there's a trend. We can see a trend. We can see that it looks like the more alcohol somebody consumes, the longer their reaction time is. That makes sense. And it looks like it's pretty linear, which means we could draw a line through it and that would fit pretty well. Sometimes you have a scatter plot that doesn't look this neat. It just looks like snow. And if that's the case, then you just don't see a relationship. And that's perfectly legitimate. In this case, we do. All right, so that's with two quantitative variables. Now let's look at qualitative variables. And we're going to look at two things here. One is a contingency table. And then there's also a clustered bar chart. So in this example I made up, we've got different people and whether they chose candidate A or candidate B. And we want to know, is there a relationship between the gender and which of two candidates they voted for. So let's go over to SPSS and we'll look at this example. So there's our example. To get that cross-tabulation, it's called a cross-tabulation, we're going to go to Analyze, Descriptive Statistics, Crosstabs. And it really doesn't matter which one you put as the row and which one you put as the column. Just put one of them as the row and the other one as the column, click OK. We do that. Here's our cross-tabulation. This just tells us that there were 6 females who voted for candidate A, 8 males who voted for candidate A, 7 females voted for candidate B, and 4 males voted for candidate B. Okay, so that's the most basic one. It just gives us the frequencies. Let's add something now. So let's go back to Analyze Descriptive Statistics, Crosstabs. And if we click on Cells, Let's first look at the row percentages. We'll click continue and click OK. If we look at row percentages, this tells us that, do you see here that every row adds up to 100%? This allows us to say, of all of the females, who did they vote for? So of the females, 46.2% of all females voted for candidate A. 53.8% of all females voted for candidate B. And then of all the males, 66.7% voted for candidate A and 33.3% voted for candidate B. Okay, so sometimes that's what you want to look at. Sometimes, depending on the scenario, you want to compare the within each row. Now, what if we wanted to compare within each column? Well, we go back to cells, but this time pick column percentages and click continue, click OK. Now this tells us of all of the people who voted for candidate A, so now each column is 100%. So of all the people who voted for candidate A, 42.9% were female, 57.1% were male. Of all of the people who voted for candidate B, 63.6% were female and 36.4% were male. The final thing we could do, which is a little bit less useful, is, for comparison anyway, is we could look at the total percentages. And then that would tell us of all of the 100% of people, 24% were females who voted for candidate A. Okay, so that just gives you the whole percentages. Now, what I don't want you to do is make it confusing. It's also a little bit cheating, and do all of them at one time. And I say it's cheating facetiously, but it's confusing, but I want you to pick one. So for all of the examples that we do, I want you to pick the one that's the most appropriate. Okay. All right. So that's the cross tabulations. We can look at clustered bar graphs as well for qualitative data. Let's look at that. So if we go to Graphs, Legacy Dialogues, Bar, let's look at a clustered bar graph. So let's put, to start with, let's put gender for category axis and define clusters by candidate. And we'll see what we get. Okay, so gender is our category axis and candidate is the defined clusters by. Click OK. And what that does is it splits up where you've got the females and who they voted for, and then the males and who they voted for. So this allows us to see of all the females and compare which candidate they preferred. It looks like the females preferred candidate B, and it looks like the males preferred candidate A. Okay, and we could also switch those two, going back to bar chart, clustered. We could put candidate as the category axis and gender as the clusters. And if we do that, it makes it a little easier for us to say within candidate A, more of them were males than females, whereas within candidate B, more of them were females than males. Okay? So that sort of corresponds to the row and column percentages. All right, now let's look at what do you do when you want to know about the relationship between a qualitative variable and a quantitative variable. Well, really what we're doing here is we're comparing groups. So here's the example we're working with here. We've got two treatments and the severity of the migraines, where higher numbers mean worse headaches. So let's compare the placebo group, the severity of their headaches, to the medication group. Okay, and what we're going to do here is we're going to do a box plot. Now, we're going to get into box plots in more depth a little bit later, and you'll see exactly what everything represents. Don't worry about it now too much. But let's go to Graphs, Legacy Dialogues, Box Plot. And we'll do a simple one. And severity of symptoms is the variable. That's our numeric variable that we want to compare. And then the treatment is the categorical variable. So that's going for category axis. So click OK. And you see this is our box plot. So you can tell from looking at this, let me tell you briefly what some of this represents. Basically, this tells you what all the data is from lowest to highest. And then the box is the middle 50%. Okay, so if you look at the lowest and highest for the placebo group, it's much higher than the lowest and highest for the medication group. Same thing for the middle 50%. So the middle 50% for the placebo group is much higher than the middle 50% for the medication group. Don't worry too much about what that represents. Just know that for now, this tells us that this data is higher than this one, typically. Okay, so that tells us that indeed it looks like the placebo group had worse headaches than the medication group, which means that it looks like the medication is helping. All right, so that's it for this lesson, and as always, let me know if you have any questions. I'm always happy to help.